Hi everyone, welcome back. I hope y'all are doing great today. Are y'all ready for another math lesson? Well, let me start off with a question for y'all. What did the geometry teacher say when his parrot went missing? Polygon. Okay, well, let's go ahead and get started because today we are on Module 3, Chapter 10, Length, Area, and Volume. So for the very first problem, we are giving this information, and it wants us to determine how many mouthfuls are in a gill, in a cup, and in a pint. And so the first one that we'll go ahead and get started with is determining how many mouthfuls are going to be in a gill. So if we know that 1 jigger is equal to 2 mouthfuls, that means that 2 jiggers is going to equal 4 mouthfuls because we are doubling it. And that also means that it is equal to 1 jack. So 1 jack is equal to 2 jiggers. Now we'll go ahead and double that, and we'll go ahead and get that 2 jacks is going to be 8 mouthfuls, which is equal to 1 gill. So we have that 1 gill is equal to 8 mouthfuls. Now we'll go ahead and determine how many mouthfuls are in a cup. Well, we just determined that there is 8 mouthfuls in a gill, correct? So we'll go ahead and double the number of gills to 2, which will also double our number of mouthfuls to 16. So 2 gills is equal to 16 mouthfuls, which is the same thing as 1 cup. And we have that 1 cup is equal to 16 mouthfuls. And finally, how many mouthfuls is there in a pint? Once again, we just determined that there are 16 mouthfuls in a cup, correct? Okay. Once again, we'll go ahead and double the number of cups to 2, which will also double our number of mouthfuls to 36. So 2 cups is equal to 36 mouthfuls, which is the same thing as a pint. And we can check over here on our provided data. 2 cups is equal to 1 pint. Therefore, 1 pint is equal to 36 mouthfuls. And then here we have just created a little visual so that we can see that 1 gill is equal to 8 mouthfuls. And then we have that 1 cup is going to equal 16 mouthfuls. And then the 1 pint is going to equal 36 mouthfuls. Okay, now for the second problem, it wants to know if we have a pail and we put in 1 mouthful, 1 jigger, 1 gill, 1 jack, 1 cup, 1 pint, 1 quart, 1 bottle, and a gallon. Is our pail going to overflow? Is it going to be evenly filled up? Or is there going to be room for more? Well, the first thing we did is we went ahead and converted everything into mouthfuls to make it easier to understand the concept. And so we determined that 1 pail is equal to 512 mouthfuls. And then we'll go ahead and put in our gallon. And we know that 1 gallon is equal to 256 mouthfuls. And then we'll go ahead and put in our bottle. And our bottle is equal to 128 mouthfuls. Then we'll put in our quart. And that is equal to 64 mouthfuls. And then our pint, which is equal to 32 mouthfuls. And then we have our cup. That is 16 mouthfuls. And then we have gill, which is 8 mouthfuls, a jack, which is 4 mouthfuls, and then we have a jigger, which is 2 mouthfuls. And finally, we'll go ahead and have a mouthful. And as we can see, we have room for 1 more mouthful in here. But if we want to determine this mathematically, what we know is that 1 pail is equal to 512 mouthfuls, correct? So we'll go ahead and subtract all the mouthfuls that we just put into our pail. And then when we do that, we're going to get that our total is going to equal 511. So if it fills up with 512 and we put in 511, that means that we have room for 1 more mouthful. That all was a mouthful. Now, okay, for problem number 2, we are asked to determine the area and the perimeter of this figure. And we know that this is going to be a triangle, correct? So in order to find the area of a triangle, we use the formula half times b times h, which means b is going to be our base and h is going to be our altitude. And so this is our base, because this is how long this is, and this is going to be our height of our figure here. And now we'll just go ahead and plug that into our formula, and we'll go ahead and get that our area is there. And then for the second part, we'll go ahead and find the perimeter. And for perimeter, we have that our formula is a plus b plus c, which simply represents the sides of our triangle. And we'll go ahead and put those in and add them together, all three sides, and we get that our perimeter is 200.9 meters. Okay, and now this is going to be our second figure that we are given for problem number 2. And once again, it wants us to determine the area. And because this is also a triangle, we'll be using the same formula, 1/2 base times height. But this right here is going to be, sometimes it can get a little hard to determine, well, which one's going to be my base and which one's going to be my height. So let's go ahead and just turn this over, and this will give us a better idea. So here's our right angle, correct? And we know that the side across from our right angle is our hypotenuse. Therefore, this is going to be our base and then our height. So we'll go ahead and plug those numbers into our formula, and we'll get that our area is going to be 245.76 inches squared. And remember, area is always measured in squared. Okay, now for the perimeter. Once again, the perimeter is simply adding up all the sides of our triangle. And when we do that, we'll go ahead and get that the perimeter for this triangle is equal to 76.8 inches. And now we are given our third figure here for this problem, and we are once again asked to determine the area. Once again, this is a triangle, therefore it's going to be 1/2 base times height. But let's go ahead and clean this up a little bit so that we're able to find our numbers a little bit better. And now we know that our base is equal to 5.2 centimeters and our height is going to be 2.6. And we'll go ahead and plug that into our area formula, and we'll get that our area is 6.76 centimeters squared. And then let's go ahead and do our perimeter here. And our perimeter, once again, is going to be the measure of all of our sides. So we'll go ahead and plug those in. We have 3.3 because that's the side, that's what this measures. We have our other side, 5.2, and our third side, which is 8.3. So we're not measuring the height, we're measuring perimeter, which is just the sides of our actual triangle. And so we get that our perimeter is equal to 16.8 centimeters. Okay, now for problem number 3, we are asked to calculate the area of the large circle, and then the area of the small circle, and the area of our square. But everything's kind of confusing, there's a lot going on, so let's go ahead and get the information going here. And we'll go ahead and start off with our square, where we are given the information that our square is going to have 14 units in length on all of its sides. So we know that part, and we know that the area of a square is going to be a squared. That's going to be our formula, and a represents the sides of our square. So we'll go ahead and plug in our 14 into our formula, and we'll get that our area of our square is equal to 196 units squared. Okay, now we want to know what is the area of the small circle. And then this is the information we were given, that there's 14 units on the side. And we know that the area of our circle is given by pi r squared, with r being the radius. And we know that the radius of a circle is going to be half of the diameter. So that means that this is 7 units. And how do we know this is 7 units? Well, we know that this is 14 units, and this measures the same thing. Therefore, half of it is going to be 7 units. And we'll go ahead and just plug that into our formula. And then we get that our area for the small circle is going to be 49 pi units squared. Okay, now we want to calculate the area of the larger circle. And that's our information. And we know that the area of a circle, once again, is going to be pi r squared. And then we're like, okay, so we don't have the radius for our large circle. We have the radius for our small circle, but now we need to know the radius of our larger circle, correct? Okay, so how can we do that? We'll go ahead and use our Pythagorean theorem because we are already given two sides here, and now we just need to find our third. And we know that r is going to be our hypotenuse. That's the number that we don't have. So we'll go ahead and plug in our sides. 7 squared plus 7 squared is equal to c squared. And we'll get that c squared is equal to 98, which is our radius. And now we'll go ahead and plug that into our formula now that we figured our radius out. And we'll go ahead and get that our area is going to equal 98 pi units squared. Okay, and then for the third part, we want to know what is the area of the region between the two circles. In order to do so, what we're going to do is we're going to take our area of the large circle and we're going to subtract the area of the smaller circle. And whenever we do so, we're going to get 98 pi units minus 49 pi units squared, and that's going to give us 49 pi units squared. So that is going to be the area of the region between these two circles. Okay, and now for this third part, it wants to know which one is bigger. Which area is bigger? The area from our smaller circle, which we determined was 49 pi units squared, or is it going to be the area between our circles, which we determined was 49 pi units squared? Well, we can see that they are the same, so neither is bigger than the other. Okay, now for problem number 4, we are given this figure and it wants us to determine the volume of the circular cone, the volume of the cylinder, and the volume of the sphere. But let's go ahead and take this apart and let's go ahead and focus on one thing at a part. And we'll go ahead and start off with finding the area of our circular cone. So this is what our circular cone looks like. And we know that the volume of the circular cone, let me go ahead and move this over a little bit so that y'all can see it just a little bit better because it kind of gets in the way a little bit there. Awesome. Okay, so we'll go ahead and continue on. The volume of a circular cone is given by the volume of the cone, which is 1/3 base times height, or b times h, which is going to be our base area. And our base area is equal to pi r squared. And then we are given this information right here. So we are given that the base area is pi r squared and our base is r. And so then our height is going to be 2r. And we'll go ahead and just plug that into our formula. And we'll get that the volume of our circular cone is going to be 2/3 pi r cubed, because volume is measured in cubed units. All right, now let's go ahead and focus on the volume of a cylinder. So this is what our cylinder looks like. And then once again, we know that our base area is equal to pi r squared. And so now we'll go ahead and plug that in. Pi r squared, which is our b, times our height, which they gave to us that it was 2r, and that is equal to 2 pi r cubed. And so that's going to be the volume of our cylinder. All right, now let's look at our sphere. And for our sphere, we are given that our formula is going to be 4/3 pi r cubed. Okay, and then for the other part of our problem number 4, it wants us to demonstrate that the ratio of the volumes of the cone to the sphere to the cylinder is a 1 to 2 to 3 ratio. So how are we going to do this? What we're going to do is we're going to take each volume, and we're going to divide it by the volume of the circular cone. And so, for example, this is our first one. So our volume of the circular cone is 2/3 pi r cubed, and we'll go ahead and divide that by the volume of the circular cone, which is the same thing. And when we do that, we'll get that this is equal to 1. And then we'll go ahead and take the volume of the sphere and divide that by the volume of the circular cone. And when we do that, that'll give us 2. And then we have the volume of our cylinder, and we'll go ahead and divide that by, once again, the volume of our circular cone. And when we do that, we get 3. So now, as we can see, the ratio of the volumes of from the circular cone to the sphere to the cylinder is going to be 1 to 2 to 3 ratio. Okay, so now for problem number 5, we are given this right here, and it is asked for us to determine what it is, and it wants to know how to figure out the surface area. So this is going to be a trapezoid prism, and we know that to determine the surface area of a trapezoid prism, we're going to use the formula 2b plus ph. And what we're going to do is we're going to flip this around a little bit better so that we can kind of see it a little bit more. We don't need all the values. And we'll go ahead and get our area base, which is going to be 1/2 a plus b times h. And then the top length is going to be a in our formula. And then b is going to represent our bottom length. And then h is going to represent our height. Remember, we're determining the base area. So this is talking about the surface of the base. So when we flip this over, this is one side, and then of course it has its second side. And so we determined that our A is 26 centimeters, B is 17 centimeters, and H, our height, is going to be 12 centimeters. And we'll go ahead and plug that into our formula here, and we'll get that our area base is equal to 258 centimeters squared. Okay, and now we'll go ahead and pull that back up. And now the perimeter is going to be A plus B plus C. Once again, perimeter measures the length of our sides here. And we're going to use that our perimeter is 12 plus 17 plus 15 plus 26. Remember, we're not using this number right here because this is measuring the height. We don't want the height. We want the perimeter, how much each side measures. Okay, now that we have determined that, we are ready to find out our surface area because we already determined the base, the perimeter, and the height. So now we'll go ahead and plug that in. And we know that our base, which we determined, was 258 centimeters. And then we determined our perimeter, which is 70 centimeters. And our height, which is 2 centimeters. This is the height of our prism here. And when we plug that in, we get that the surface area is equal to 656 centimeters squared. Okay, and then for the second part here of number 5, we are given this figure, and once again we are asked to determine what this is, which is a right triangular prism, and to find its surface area, which we'll use the same formula for surface area as 2b plus ph. Remember that b is going to be our base area, and that p is going to be the perimeter, and h is going to be the height of the triangular prism. Now what we can see is we have the height here, but we don't have the base or the perimeter. Once again, we're going to repeat the same step, and we're going to find out what B is and what P is. And so we'll go ahead. This one's a little complicated to look at, so let's go ahead and take it apart. So this is what the top area of our right triangular prism looks like, correct? And so we'll go ahead and find the base area of it, and that's going to be 1/2 base times height. And we know that the base is going to be 6 and the height is going to be 8. We'll plug that into our formula, and we get that the base area is going to be 24 meters squared. And now to find the perimeter, we're going to add up all our sides here. And then we have 1 side, 2 sides, 3 sides. When we add those together, we'll get that our perimeter is equal to 24 meters. All right, now that we have calculated our base area, our perimeter, and our height, we are ready to find the surface area for the entire figure. So we'll go ahead and determine that we know that our base is 24 because we figured that out, and our perimeter is 24. And our height is going to be 5 because now we're trying to find the surface area for the entire figure, correct? Not just our triangle. We want the whole thing. So this is why 5 is going to be our height for the surface area of this right triangular prism. So when we plug in our base, our perimeter, and our height into our formula, we get that the surface area is equal to 168 meters squared. Okay, y'all, and for problem number 6, we are given this lovely figure right here, and as we can see, we have a cylinder, and then we have 2 hemispheres, which when we put them together, that equals 1 sphere together, and it wants us to determine the surface area, and we know that the surface area of a sphere is given to us by 4 pi r squared. And then the surface area of a cylinder is going to be 2 pi RH. And then in order to get the total surface area of the whole figure, we have to combine both of our individual surface area for our sphere and our cylinder. So we will add those together to get that our surface area is going to be equal to 2 pi times 4.5, which is going to be our radius. And our radius is 4.5 because our radius is going to be half of our diameter, which is 9. So 4.5 is half of 9. And of course, this is going to be our height, or 22. And so we plug those into our formula, and our surface area for this entire figure is going to be 877 feet squared. Okay, and now we want to determine the total volume. We just figured the surface area. Now we want to determine the volume of this figure right here. And in order to do so, we have to figure out the volume of all of the 3 individuals. So in order to find the sphere volume, our formula is going to be 4/3 pi r cubed. And then our volume of a cylinder is going to be pi r squared times height. And then we'll go ahead and combine these two, correct? So we'll do 4/3 pi r cubed plus pi r squared times height, and we'll combine those together, and that's going to give us our total volume of this figure. And we get that the volume is equal to 1,781 feet cubed. All right, and for the last part of our problem here, we are given this lovely figure as well, and it wants us to determine the figure's volume and the surface area. Once again, there's too much going on, so let's go ahead and take these apart and focus on one thing at a time. All right, so first of all, let's start off with our cylinder. To determine the volume of a cylinder, we're going to use our formula pi r squared times h, which is height. And looking at this picture, we know that our radius is going to be 2, and our height is going to be 12. And now let's go ahead and take a look at our cone. And the volume of our cone is going to be determined by 1/3 base times height. And then we look and we're like, oh no, guess what? We are missing the height of the cone here. We have the base, which is 2, but we don't have the height. How are we going to figure that out? Well, that's when the Pythagorean theorem comes in handy, which the Pythagorean theorem is going to be a squared plus b squared is equal to c squared. And then we know that we're missing a squared. We have b, which is 2, and then c squared, our hypotenuse, is 4. So we'll go ahead and put that into a formula, and when we solve, we will get that our radius here is going to be 3.46. I said radius, totally wrong. I meant our height, excuse me. So once again, now we have our information. Our base is 2, and our height is going to be 3.46. Okay, now that we have determined the volumes for both of our figures, the cylinder and the cone, we can go ahead and figure out the total for this figure, our total volume. And that is going to be, we're going to add together both of our volumes of our figures to get the total volume of this figure. And whenever we do so, we'll get that our volume is equal to 165 meters squared. Okay, and now we want to determine the surface area of this entire figure. But once again, our cylinder surface area is going to be represented by 2 pi RH. Our cone surface area is going to be pi RS. And our circle area is going to be pi R squared. So what we're going to do is we're going to add up all of our 3 surface areas, and that's going to give us the total surface area of the entire figure. So we'll plug that in. And we'll get that our surface area is equal to 188 meters squared. All right, y'all. Well, that was it for today. I know that was a lot, but lots of fun, right? So I hope that y'all enjoyed everything, and I guess I will see y'all on our next math lesson. Y'all have a great day.